Hey guys, it's Dr. Calkins. A little bit further into week 10, chapter 8 material, you're going to find recognizing reactions, and we have 5 to figure out. So the first one, we have, say, I'm going to use generic alphabetical letters just to make it simpler. We're going to have A plus some X, and they join together to make AX. We kind of saw this in the other video with, say, hydrogen and nitrogen, or hydrogen and chlorine or something like that, hydrogen and iodine. But you have 2 different molecules and they join into one. This is a very recognizable reaction because we call it a combination reaction. We're combining A and X either by Lewis dot connections through covalent bonds or maybe by crossing charges or something of that nature. The easiest way to recognize this is typically these are going to be 2 elements and you get only one product. The easiest way to recognize it, regardless of what elements they might throw at you, always look for this one product to know that it's a combination. The easiest way to recognize it. In real life, we could compare this to, say, getting married. So this is kind of like the marriage reaction in chemistry. Still have to balance it and things like that, but for just recognition purposes, find one product and you know it has to be combination. So in life, if there's marriage, unfortunately, sometimes there's the opposite. So if you were to take AX and then reverse it, kick out A and kick out X, sometimes, unfortunately, divorces are messy and so are chemical reactions, so not always is it just 2 products, there might be more. But this would be called a divorce-like reaction, or in our case, decomposition. Much like a divorce in that kind of analogy, because they were together and now they're separated, and then they could have some kids or cars or who knows what left over as a remainder. But what's most important here is these could be elements or compounds, depending, but there's at least 2. And notice what we started with was only one reactant. And that's really the clue that we need to order to recognize the decomposition, is it's only going to have one thing in front of the arrow, it's only going to have one reactant. So if we have marriage and divorce, we have this other one that's very common, and it's going to be a big player coming up in some later chapters, especially in 2 weeks. This one we have A by itself, we have this BX kind of compound, and then they switch. So notice A and B are now switching places. So in chemistry we call that single replacement. It's called single replacement, or some books maybe displacement, but single replacement because A is the single by itself and BX is almost like this married couple, and then somehow A runs off into the sunset with X and kicks B to the curb. So in life, what do we call that? I would call it the homewrecker reaction. It's kind of like cheating. B and X were what we thought hopefully and happily married, and A changes X's mind. B finds the stuff on the curb when he comes home. So what's important about this reaction here is notice A is typically an element, could be in a diatomic form, but it's an element by itself. It's alone, it's single. It's like a bachelor, bachelorette. Over here though, we have this compound, and notice in the products we have a new compound and now this new element. So the element changed, the compound changed, but more importantly, somebody was single by themselves before and somebody was single by themselves in the end. They just happen to be different. So as we get to this reaction later on, we need to worry about when will this actually happen, because it doesn't always work. It's going to happen when A is better than B. And that happens in real life. If you're married to B, whoever they are, and A comes along that's better, got a fancier car, job, who knows, that would be a better match. Be more security in that kind of situation. So for us, we're looking at metals and activity series. So we have an activity series that we'll give you and let you use on the exams and the homeworks, and it's in some of our labs coming up. That activity series, we want A to be higher on that list than, say, B. Because nobody wants to marry down. If A were a worse partner, a less active metal, then there'd be no reason for B to ever leave X. But if A is more willing to give up its electrons, maybe they'll switch. We'll talk about that in a later idea. This is going to be a major feature of week 12. It's not something we need to worry about yet. What we need to worry about, though, is if you're by yourself, there's another compound, and you switch, just one switches, that's single replacement. Another one is, what happens when A has a partner and B has a partner? But then, much like that example in the balancing equation video, what happens when now they both switch? So if they both switch, instead of single replacement, we would call this double replacement. So in double replacement, it's not a marriage, it's not a divorce, it's not a home record. This is kind of like Game of Thrones wife swap or something, who knows? Husband swap doesn't matter. It's like the TV show wife swap in a sense. We had two married couples and then we allowed both of them to switch. So, whether it's 60s and swinging, who knows? But what's most important here is we have two compounds and we have now two different compounds. Nobody is by themselves ever. So there's always a partner with somebody, and that's double replacement when they both switch. Much like this one requires a more active metal, somebody higher on this activity series that we'll teach you about later. But here what matters when this reaction works, which is our last video for this particular chapter, one of these has to be a solid, a liquid, or a gas. Solids will be the major portion. We call those precipitates. Whoever's the precipitate up here, one or the other. The other one will be called a spectator ion. And that's because spectator ions are soluble in water. Precipitates are insoluble in water, and that's a major feature of this chapter. The liquid that we're going to see almost always is water. Those are in neutralization reactions, which are just a subtype of double replacement. It is double replacement, but in this case we produce a water that we can't see. Typically heat is exchanged so we can feel it, we just can't see it. And this precipitate idea, again, something that we can see with an insoluble solid. The gases aren't too cool. H2S is pretty common. We don't really see it in Intro Chem much at all. H2S is the fart molecule. It's a terrible reaction to run in class and sneak up the room. So that's one that we're not really going to see, but we will see precipitates. This will be a big feature of week 10 coming up. And we'll talk about the solubility table and how it works. And then water is going to be a big feature of week 11 coming up next chapter. One more reaction left. Last one, there's no fun way to make an analogy with this one. It's just blowing things up. So you take some organic molecule, let's just say CH with some question marks. Doesn't really matter who it is. You can even add in alcohols or something of that nature. If this were C8H18, it would be octane in your car. You suck in oxygen through your car, and you produce CO2 and water. Because we have this organic, and because these three over here never change, you will always see oxygen. It doesn't necessarily have to be in this position, it could have been over here, but if you see oxygen and you see carbon dioxide and water as products, you know already that since these never change, this is a combustion reaction. And our book uses this exclusively for combustion. Other books might have any other reaction with oxygen, but we're going to stay with what our book has, and this is an organic combustion reaction. So let's give you one example and see if you can kind of pick through the pieces. Kind of zoom out a little bit and see if we can get most of these on the same slide together. We're going to leave out combustion because it's so specific, easy to recognize because of it. And I'll write a little bigger. So if we were to have, say, this reaction, bit, but if we have this reaction, notice bromine and chlorine are by themselves. Aluminum had a partner, chlorine. Aluminum had a different partner, bromine. Turns out this is a reaction that won't actually work because bromine is less active than chlorine. As you can see from the periodic table, chlorine is higher on the periodic table than bromine, so it's going to be more suitable with aluminum than bromine. But that's a different chapter. What's most important for this chapter is, did it have one product? And definitely no. Did it have one reactant? Definitely no. That's the process you go through, because if it has one product, we knew it was marriage. It was called combination. It had two, not one. If it had one reactant, this one has two. If it had one reactant, it would have been that divorce, and that would be decomposition, and it's not. Then our only choices are combustion, but no O2, no CO2, no water. So definitely not that one. Most students get down to this process of, is it single or double replacement? Both of them have two things before, two things after, so that makes it a little trickier. But if you realize this is just a diatomic single molecule, that's the bachelor, bachelorette, it could switch with chlorine. So in this case, we're actually no reaction, but in any case, it is single replacement because bromine is singly by itself, no metal partner. Chlorine is by itself, no metal partner. They would both need partners on both sides to be double replacement. So this is a single replacement reaction. And we'll get a lot of practice of those coming up, especially in week 12, but also in the labs later in this chapter. And that'll give you a decent head start on how to identify reactions that are common in Intro Chem. See you next time.